Welcome to this video on two sample hypothesis tests with independent means. Let's begin. After watching this video, you should be able to conduct a two-sample hypothesis test for two independent means. Let's review the steps in a hypothesis test. First, we must determine whether the requirements for the hypothesis test are satisfied. Then we can state the null and alternative hypotheses. We then proceed to use either the p-value or the critical value method to test the hypotheses and make a decision to reject or fail to reject, or in other words, to retain the null. Lastly, we write a statement to summarize our findings. Let's work an example. A school wants to know if a new teaching method improves student performance. They randomly assign students to one of two groups. One group is taught using the traditional method, while the other is taught using the new method. Use the information provided to determine if there's a statistically significant improvement in the mean exam scores in the treatment group at the 5% significance level. So down here you can see we have some data. So there were 32 students who were taught using the traditional method. They scored a mean exam score of 72% with a deviation of 7%. The students who were taught using the new method, there were 36 of those students. They had a mean exam score of 75 with a standard deviation of 5%. So let's answer some questions about this problem. First of all, how many samples are we working with? Well, as you can see, we have two groups of students or two samples. And then what type of data are we working with? Well, here is our summary right here of the data. So you can see that it is quantitative data because you have a mean and a standard deviation that suggests quantitative data, and your exam score again is quantitative. So we do have two samples and we do have quantitative data. So we have to answer this third question, which is, are these means independent or dependent? And again, I encourage you to pause the video, figure out your response, and then unpause it. So in this case, the means are independent. So how do I know that? Well, we have two different groups of students, and we don't have anything to suggest any way of pairing them or matching them. We don't have data on the same student before and after the treatment. In other words, you don't have one student being taught in both the traditional method and a new method. You have one group of students being taught with a traditional method and a completely different group of people being taught using the new method. So there is no pairing or matching, so we have independent means. So let's go over the requirements for this kind of test. First of all, we need each sample to be a random sample. Secondly, we need independence, meaning that if we are sampling without replacement, the sample size has to be less than 5% of the total population. Also, we just need to make sure that each data point is independent from the others, and that's also another way to measure independence. Next, we have our normality requirements. So if we are going to model this using either a T distribution or a Z distribution, we say that the population has to be normally distributed or the sample size has to be greater than 30. And remember, that's the requirement of the central limit theorem. So this is something a little bit new. You probably haven't seen this before, and that's the requirement of equal variances. So when we get to conducting this test, if we want to use the critical value method, then we are going to have to find the degrees of freedom. And in order to use this particular equation to calculate the degrees of freedom, then we require roughly equal variances. Now, there is a way to calculate the degrees of freedom without this requirement of equal variances, and that's called a Welch t-test. You don't actually need to know how to do that. We will use technology to do that for us if we need it. But just be aware of this. Okay, so let's see if our requirements have been met. So first of all, is each sample a random sample? We are going to assume that it is. We know that at the very least, the students were randomly assigned to one of the two groups. Okay, independence, we are going to assume that the students in these two groups is less than 5% of the population of all students in the world. That's pretty reasonable. And we will assume that one student's score or performance on the exam didn't impact any of the other scores. So normality, we either need to be told that the exam scores are normally distributed, or we need n greater than or equal to 30. And as you can see, both our sample sizes are greater than or equal to 30, 32, and 36. And again, it has to be met for both sample sizes, not just one of them. So last but not least, we have equal variances. So remember, the variance is the standard deviation squared. So that would be 49 and 25. And so we will say they are close enough to use this formula to calculate the degrees of freedom. So now that we have our requirements met, we're going to move on to writing our hypothesis statements. So recall that we said that we have two samples, we have quantitative data and independent means. So here is our buffet, if you will, of types of hypothesis tests and their associated null hypotheses. So again, take a minute, pause this video, see if you can figure out which of these we are working with and what is the appropriate null hypothesis to use. So if you said two means with independent samples, that is correct. So this is going to be our null hypothesis. So we know that our null hypothesis is that the two means are the same, mu1 is equal to mu2, or if we rearrange this algebraically, we can rewrite this as mu1 minus mu2 is equal to 0. But before we can go any further, especially before we can form our alternative hypothesis, we need to define our populations. So just for the sake of convenience, let's just say that population 1 is going to be the students with the traditional method, and population 2 is going to be the students taught with the new method. Again, this assignation is completely arbitrary. You could have done it a different way. Just note that the way in which you define your populations is going to determine the inequality that you use in your alternative hypothesis. So be aware of that. Okay, so we have our null hypothesis. So then, remember, we want to look for that key phrase, the key phrase in this problem that tells us what our alternative hypothesis is going to be, is that it asks if there is a statistically significant improvement in the mean exam scores, meaning that we think that the average of the second group, the treatment group, that mu2 is going to be larger than mu1. So if mu2 is larger than mu1, that means mu1 is less than mu2. Or we can also write it as mu1 minus mu2 is equal to, mu1 minus mu2 is less than 0. Okay, so now we are ready to go ahead into the trenches and start doing our hypothesis test. So recall that we can use either the critical value method or the p-value method. And again, I will demonstrate both in this video. Traditionally, you would only just pick one or the other, not both. Okay, so whether you're using the critical value method or the p-value method, you're going to have to generate a test statistic and or the p-value. You can use this, you can do this either using technology or using a manual calculation. So you have lots of options with your technology. And when you do that, we have a t-stat of negative 2.05 and a p-value of 0.02222. All right, if you want to do a by-hand calculation, you have to use this fun, exciting little formula here to compute your test statistic. Okay, and if you're using the critical value method, that would be enough. If you're using the p-value method, then you have to use a t-table to look up the p-value associated with this t for the given degrees of freedom. And again, just remember that the tables that you use are going to give you less precision than the technology. So let's say that we are using the critical value method. Okay, so we are given, first of all, a 5% significance level and a left-tailed test. So remember, since we're using a t-test and not a z-test, finding the critical value is going to be a little bit more complicated. You might recall when we did a one sample mean hypothesis test, we had to find this thing called degrees of freedom, which is the sample size minus 1. But this time, right, we have two different samples and we have two different sample sizes. So now what are we going to do? Well, as I mentioned before, if we can assume equal variances, we can use this formula. So we're going to take n1, which is 32, plus n2, which is 36, and then subtract 2. So that's going to give us 66. So that's our degrees of freedom. And when we plug that into a t calculator, we find that the critical value is about negative 1.67. Okay, so now what do we do? Well, let's just review what the critical value method entails. So the critical value method says that if our test statistic happens to land in this shaded critical region, then we will reject the null. And if it lands over there in the unshaded, outside of the critical region in the unshaded area, then we are forced to retain the null. So as you saw on the previous slide, we have our test statistic of negative 2.05. So that is landing squarely inside of the critical region. So that leads us to reject the null. So again, I'm going to do this exact same thing using the p-value method. And again, normally you would pick one or the other. You would not do both in the same problem. Okay, so we compare the p-value to alpha, which is the significance level, and recall if the p-value is less than alpha, we will reject the null. If the p-value is greater than alpha, we will retain the null. Okay, so again, we use technology to calculate our p-value, as you can see here. And so when we compare our p-value of 0.0222 to alpha, we can see that the p-value is smaller than alpha, and that leads us to reject the null, which is a comfort because that's the exact same decision that we arrived at using the critical value method. So now it's time to make a decision, and again, both methods have led us to reject the null. So now we just have to write a statement to summarize our decision. So remember, our statement is very formulaic. If we decide to reject the null, we have to say that there is sufficient evidence to support the claim that, and then we rewrite our alternative hypothesis, and then we say at the blank % significance level. Likewise, if we decide to retain the null, we have a similar formulaic statement. We say there is insufficient evidence to support the, and then we write the alternative hypothesis, and then we write at the blank % significance level. So which one are we doing this time? We are going to reject the null. That's what we decided to do, right? So since our decision was to reject the null, we have to follow this formulaic statement. And so where are we going to find our alternative hypothesis? Well, we're going to just lift it directly out of our problem statement. And it says there is a statistically significant improvement in the mean exam scores in the treatment group. So remember, the treatment group is the new teaching method. So then I'm just going to say there is sufficient evidence to support the claim that the new teaching method, that's the treatment group, results in a statistically significant improvement in the mean exam scores at the 5% significance level. So before we wrap up this video, I want to remind you about this idea of statistical significance versus practical significance. So we know that on a statistical level, there is a statistically significant difference in these mean exam scores. But if you look at them, look at the differences in the averages. Or the difference in the average, right? It's 72% versus 75%. That's only a 3% increase. So while it might have statistical significance, I want you to think about, is it practically significant, right? Is it enough to make the new method worthwhile? So other factors that people would think about if they were going to implement this new method is, for example, cost, right? What if it costs a ton of money, millions of dollars for this new curriculum? What if, as an instructor, as a teacher, it takes you twice as long or 3 times as long to prepare your materials to do your lesson planning than it did with the traditional method, right? You can't just zoom in and say, hey, it's statistically significant and walk away. You have to think about, right, the environment, all of the other factors that are going to go into making this decision. So again, I just want to remind you that just because something has statistical significance doesn't mean it's also practically significant. That doesn't mean necessarily that something should be adopted or used. So in conclusion, now that you have watched this video, you should be able to conduct a 2-sample hypothesis test for 2 independent means.